Hello dear students, welcome to Pen and Paper Chemistry on YouTube. We start with the topic for the day, Faraday's laws of electrolysis. This is on request of one of the subscribers and I am sure this will be helpful for others as well. Before we go on to the Faraday's laws, we need to just break down the word electrolysis. Electro comes from the word electrons, and the flow of electrons generates what we call as electric current. Lysis, on the other hand, means breaking up or breaking down. So, the breaking down of a substance when taken in molten state or taken in aqueous solution form on the passage of electric current through it is what we call as electrolysis. Take for example Ag positive, that means silver ions present in a solution take up electrons and form silver atom. This gain of electrons is nothing but an example of reduction. On the other hand, we have taken another example where copper loses electrons to form copper ions. Loss, L-O-S-S, O, oxidation, easy way to remember. So, loss of electrons is what we call as oxidation. In a reaction mixture or during the process of electrolysis, both the processes can take place, but the electrode at which the process takes place will be vary. It will be the cathode or the anode. The details of this we will do in the next part of the video. Here we are dealing with the mathematical aspect of it, which is the Faraday's laws of electrolysis. Faraday's first law says that when you pass electric current through an electrolyte, which is in the molten state or aqueous solution, the amount of the substance, that means the weight of the substance which will be deposited or liberated, it can be either way, like here silver will be deposited, but in the second reaction that I have written, copper will be released as ions or copper will be released as ions in solution. So the amount of substance deposited or liberated at an electrode during the process of electrolysis is directly proportional to the amount of charge passing through it. So how do we represent it mathematically? W is the weight of the substance is directly proportional to the amount of charge passing through the conductor. Now, going back to our knowledge of physics, we know that we don't measure charge. What do we measure with the help of an ammeter? Yes, we measure the current flowing through it. So let us correlate this charge to current, which is easier to measure. We know that current is the amount of charge flowing through a conductor per unit time. Now per unit time means we are talking about the time in seconds because that's the standard unit that we use. I is the representation of current, so I is Q upon T. Q is the amount of charge, T is the time interval. The unit for charge is coulomb, the unit for time is seconds. So the unit of current becomes coulomb per second or more commonly known as ampere, represented by capital A. So we simplify the formula, Q is equals to I into T. So what we can do over here is we can simply convert this W is directly proportional to Q as W is directly proportional to the current flowing through the conductor into the time. I is the amount of current, T is the length of time for which you are passing the current. Removing the proportionality sign, we have W is equals to Z I T. We put a constant over here. And what is this Z or Z? It's the electrochemical equivalent. Now if you have seen the earlier videos, I've taught you a simple method in order to define any constant. What is that method? Now Z can be written as W upon I into T. What is I into T? Current into time. It is nothing but the representation of charge flowing through the conductor. Now if this charge becomes 1, that means the amount of charge flowing through the conductor is 1 coulomb, my Z becomes equals to W. So how do we define electrochemical equivalent? Yes, give it a try. It is the weight of substance deposited when how much charge flows through the conductor or through the solution? Yes, 1 coulomb. So electrochemical equivalent is nothing but the weight of the substance deposited or liberated when 1 coulomb of charge flows through the electrolyte. As simple as that. Now, let us take an example here. How are we going to use this concept? M positive gains an electron to form M solid. Now this is any random form of element that I am taking a general representation. In other words, if there is 1 electron being passed through the solution, I am getting 1 atom of M. Right? What if I pass 2 electrons? Yes, I'll get 2 atoms of N. Now you also know that practically it is difficult to control and it is not possible for us to allow only 1 electron or 2 electrons to pass through it. So let us generalize it. Coming to 1 mole. Now if you have gone through the video on mole concept, I have explained mole clearly. Now this is a very standard representation of the amount of any substance. So if I take 1 mole of electrons, that means I will get how many mole atoms of M? Yes, if it is 1 is to 1, 2 is to 2, so 1 mole will be, yes, it will be 1 mole atoms of M over here. What does 1 mole mean? Yes, it's Avogadro number, 6.023 into 10 to the power 23 atoms, or equal to the molecular mass or the atomic mass of the substance that we are talking about over here. It could be ionic mass, molecular mass, atomic mass, depending upon what state of the substance we are talking about over here. I shall be taking a few examples later in this video only to explain the concept. So if I have 1 mole electrons, that means I am talking about an Avogadro number of electrons, which is 6.023 into 10 to the power 23 electrons. They will give me 1 mole of M, which is also equals to the atomic mass or the molecular mass. So that is 6.023 into 10 to the power 23 atoms. What is the charge carried by 1 electron? We have done it in the topic atomic structure. Yes, it's 1.6 into 10 to the power minus 19 coulombs, or if you want to take it more exact, you can say it as 1.602 into 10 to the power minus 19 coulombs. So the charge on 1 electron, how much will be the charge carried by 1 mole of the electrons? Now that you are passing 1 mole of electrons through the solution, what is the total charge flowing through the electrolyte? Yes, you multiply the charge on 1 electron by the number of electrons. So 1.602 into 10 to the power minus 19 multiplied by Avogadro number, that is 6.023 into 10 to the power 23. This comes to, actually it will depend. Here I have written 963200. It also comes to around 96480. Depending upon what value of the charge on the electron and the Avogadro number that you are taking over here. Some books you will find the calculation just 6.02. Some books you will find the charge on the electron just taken as 1.6 into 10 to the power minus 19. As an approximation, we take this value as 96500 coulomb per mole. That means the charge carried by 1 mole electrons is a constant value known as 96500 coulomb per mole, also called as Faraday constant, represented by capital F. So we introduce a new constant over here called as the Faraday constant. Now take a more specific example. Let's say I am talking about Cu2 positive. If it gains 2 electrons, it changes to Cu. In other words, now if you saw here 1 electron, 1 atom, 2 electrons, 2 atoms, 1 mole means 1 mole. In other words, 1 Faraday of charge means corresponding to 1 mole of the atom, equal to the atomic mass. Yes. 2 Faraday here, if you are passing 2 electrons means we are saying just take it as Faraday. So 2 Faraday will give you 63.5 grams of copper. Just see from the equation. Cu2 positive, it has 2 positive charge plus 2 electrons gives you copper. Now you just have to see the equation. Whatever is the charge, the number of electrons is going to give you the number of Faradays. So 2 Faradays are giving you an atomic mass of copper, that is 63.5 grams of copper. Take another example. Al3 positive plus 3 electrons gives you Al. In other words, how many Faradays of charge here? Yes, what's the coefficient? 3. So 3 Faradays is giving you how much of aluminium? What is the atomic mass of aluminium? Yes, 27 grams. So 3 Faradays is giving you 27 grams of aluminium. So from this, it becomes very, very simple. So as soon as you see the charge or the number of electrons which are involved in any change in any ionic equation, that gives you the number of Faradays of charge involved in giving you that much mass of the substance. Let's take it a step further. Here 1 Faraday of charge was giving us the atomic mass of M. Here 2 Faradays are giving us a mass equivalent to the atomic mass of copper. That is 2 Faradays are giving you 63.5 grams of copper. How much mass will you get if you are passing only 1 Faraday? Simple unitary method. 2 Faradays this much. So 1 Faraday how much? 63.5 divided by 2. Right? So that's the mass of copper being obtained if you pass 1 Faraday of charge. Coming to the next example that we have taken. 3 Faradays is giving you 27 grams. So how much of aluminium will be obtained when you pass 1 Faraday of charge through the solution? Yes, again unitary method, 27 divided by 3, that is simply 9 grams. You are passing an equivalent mass of current or charge through all the 3 solutions. M, the copper solution, aluminium solution. You are getting the mass of the substance divided by this charge that it is carrying, which I will represent as simple N. So 1 Faraday is giving you the atomic mass of copper divided by the charge, that is 2. 1 Faraday of aluminium is giving you the atomic mass of aluminium divided by 3. So if you are passing the same amount of current through different solutions, the mass of the substances obtained correspond to what we call as their equivalent mass. How do we get the equivalent mass? It is nothing but the atomic mass divided by the valency or the charge. That gives us our second Faraday's law. When the same amount of current is passed through different solutions, the masses of the substances obtained are in proportion to their equivalent masses. Take a break, go through the video again. If you have any doubts, stop at that, because we will be continuing with numericals based on this just to make our concepts stronger. Hope you've taken a short break and you're ready for the numericals. Okay. I've put in two numericals here because without attempting the numericals, this topic is meaningless. And I'm sure once we do the numericals, then you'll think, oh, Faraday's laws were so easy. Why was I getting so confused? Right? First numerical says calculate the amount of electricity, or you could also get the amount of charge in Faradays and in coulombs required to produce 20 grams of calcium from molten calcium chloride. There's a second part also to the question. We are not going to concentrate on that. If by any chance you are confident that you can attempt this numerical on your own, please go ahead, pause the video, attempt it, and then you can tally the answer that we do over here. Right, for those who are struggling with the numericals based on this, very simple. What we've got here is 20 grams of calcium is to be obtained from molten calcium chloride. Calcium chloride means the calcium is present in the form of ions. Now for this you should be very sure about your valencies. Don't worry about the atomic masses, these are usually provided. So calcium ions are to be changed to calcium atom. How will that happen? If calcium ions gain 2 electrons and change to calcium. Now we've just done that. This 2 electrons is nothing but the Faradays. Simple. If you have aluminium Al3 positive plus 3 electrons, then this is 3 Faraday. If you have sodium Na positive plus electron changing to Na, this is 1 Faraday. As simple as that. So the number of electrons gives you the number of Faradays. So that's what we are going to use over here. So what is happening over here is we are using 2 Faradays of charge. We are getting an atomic mass of calcium which is 40 grams. The question says that you need 20 grams. I'll simply use unitary method. Okay, so we have 2 Faradays and grams. So if it is 2 Faradays, it is 40 grams. If I want 20 grams, how many Faradays? As simple. So you can either put an x over here. So 2 upon x is equals to 40 by 20. Or if you see, this is just oral calculation and this gives you 1 Faraday. So you need a 1 Faraday charge in order to obtain 20 grams of calcium from calcium chloride. How do you calculate coulombs from here? We know that 1 Faraday is equivalent to 96500 coulombs. That's what we have derived earlier in the video. So simply 1 Faraday is 96500 coulombs. We don't have to do any calculations. In order to obtain 20 grams of calcium, we need 1 Faraday of charge which is equivalent to 96500 coulombs. That's the Faraday constant. Come to the second part. If the current flowing through the electrolyte is 5 amperes, for how much time do I have to pass this current in order to obtain the required amount of calcium? Again, just going back to I is equals to Q by T. Yes. Can you recall this formula? We did it in the beginning itself. So I have got is 5 amperes. Q is 96500. We just have to calculate time. So the time that we get over here is 96500 divided by 5. What do we get? Can you give me the answer? 5 times 1. 5 9s are 45, 5 3 is 15. So this 19300, what? Without unit it is senseless. This time could be anything, seconds, minutes, hours, years. Yes, here we will put seconds. Why seconds? Because we are talking about the charge in coulomb, the current is in amperes. So if you remember, we said ampere is nothing but coulomb per second. So the time that we have got over here is second. Now this is a very big answer. You can actually take it a step ahead and convert the time to minutes or hours. How will you convert seconds to minutes? Yes, you divide it by 60. How will you convert minutes to hours? Again divided by 60. So in effect what you are going to do is you will divide 19300 by 60 into 60, that is 3600, in order to get the time in hours. Can you give me an answer to this? Please pause the video. Don't be in a hurry to know the answer. It's very easy, but it's the confidence that you need to build. Yes, it's approximately 5.36 hours. It would be in your best interest to attempt more numericals like this. Going on to the second numerical, which says that a solution of aluminium nitrate is to be electrolyzed and you are using a current of 5 amperes for 2 minutes. Now this is a very lengthy numerical, right? How are we going to do it? Let's start step by step. First of all, list down what is provided to you. 5 amperes. So we know that the current is 5 amperes. 2 minutes. We know that the time is 2 minutes. And we also have learned just now that the time is to be stated in seconds. So what do we do is, I convert this minutes to seconds by multiplying it with 60. Gives me 120 seconds, right? We have to calculate the mass of aluminium obtained. So what do we have to do is, mass of aluminium is what we have to find out. We've got aluminium nitrate. We also know that aluminium has a valency of 3. So aluminium nitrate is nothing but AlNO3 whole thrice. If you are not confident about writing the formula of a compound, please refer to the video based on writing of chemical formula. Now Al3 positive plus 3 electrons gives you Al, right? Now can you guess what will be my next step? Yeah, simple. So 3 Faraday giving me 27 grams of aluminium. Correct? 3 Faraday means 3 into 96500 coulombs of electrons or charge is giving me 27 grams of aluminium. How much charge or how much coulomb is flowing through the current, through the solution? How many coulombs of charge is flowing? Yes, Q is equals to I into T. We are using the same formula in a slightly different format because we are making Q as the subject of the formula. So I here is 5, the time is 120, so we have it as 600 coulombs. Again, just apply the unitary method, coulomb and mass. So you have 3 into 96500 coulombs is giving you 27 grams of aluminium. So 600 coulombs will give you how many grams of aluminium? Just unitary method. So X gives me 27 into 600 upon 3 into 96500. Now again, pause the video. I would sincerely want you to do the calculations and give me the answer while I also calculate it. 0.0559 grams is what you get as the weight of aluminium obtained. See you soon. Happy studying.